Hi everyone, this is the continuation of assembly language notation. We have already seen register transfer notation and what is assembly language notation. Register transfer notation, as I have said earlier, it is nothing but the source address will be placed within the square bracket and the destination will be in the leftmost side, and an arrow mark will be used to indicate an assignment operation. Okay. And assembly language notation is nothing but this is an instruction format, and it consists of mnemonics usage within that instruction, whereas move, add, su, subdivision, div, jump, these are the few examples which we are used in the operations side. And in this, source will be followed by the destination while writing the instruction, and we have seen the example for uh, storing the location or storing the making a copy of location data to the register R1, and performing addition operation between R1 and R2 and storing it to the register R3. Let us see, the assembly language notation is subdivided into three categories. It is nothing but one address instruction, two address, and three address instruction. Let us grow reversely from 3, 2, and 1, because 3 address seems to be so easy compared to the 1 and 2 address. For better understanding, let us go in that order. With an example, we are going to see that these three addressing of instruction. Let us take the example as C is equal to A plus B. Whereas in register transfer notation, we know this is the uh, thing which we are using for mentioning this operation in register transfer, whereas C is the destination and arrow is used for assignment, and A and B are the locations of these data, and addition operations should be performed, and location of the source will be placed within the angular braces. So this is for register transfer notation. Let us see the same example for 1, 2, and 3 addresses. Let us start from 3 address instruction. In 3 address, the same operation C is equal to A plus B has to be performed, right? As I have said earlier, operation source followed by destination is the syntax which we are using for 3 address instruction. In 3 address locations will be used in the single line instruction. So first two address locations will be of source 1 and source 2, and final address will be of the destination. Here the operand A and B are the source. So we are writing it as A comma B, and the operation which has to be performed is addition, right? So here we are mentioning as add A comma B, and what we have to do, we have to say that result value in the destination of C. So destination is written in that position. While reading this, an addition operation will be performed after reading the contents of address location A and B, and the result will be stored on the location of C. This is for 3 address instruction. As I have said earlier, 3 address is nothing but it will be constituting of 3 address locations within the instruction. Let's go for 2 address. In 2 address, it is nothing but it consists of only 2 uh, address locations, that is nothing but source and destination. Here, to performing the same operation in 3 address, we have written in a single line command instruction, whereas here we have to think, and we have to write in 2 steps which is required to perform this same operation of C is equal to A plus B. First we will be writing move B comma C, that is nothing but the value of B will be moved to C. C is equal to B. This is the operation which will be performed for first instruction move B comma C. Then add A comma C. In this nothing but the value of A will be added to the C. Currently C is having the value of B. So it will be added with A, and finally this is the destination also. In this, C performs as the source and it is also used as an destination. Since the syntax is operation source comma destination, based on the operation which is given, the final address space which were given in the instruction will act as an source and destination also. In previous, C is nothing but move B comma C. Here C performs the role of destination alone, but here C performs the role of source and destination. And while reading this instruction, the value of C which contains the value of B, copy of B value will be added with A, and the same contents will be replaced by the result output will be rewritten into the address location of C. So to perform the same addition operation in two address, we have to write two instruction sequences. Okay.